so this first part is all about functions. It's been a while since we did that. You have two functions at the top, f of x and g of x. So what do you do when it says find fg of 0?
Multiply and plug in 0.
Yeah, you can do it two ways. You can multiply them first, or you can plug in 0 first. 0 is your x. It's actually easier to plug in the 0 first. So you plug in 0 for the f of x. And that gives you -1. And then plug in 0 for the g of x. What does that give you? Yeah, 1/2. And then since we're multiplying, you just multiply the two. So -1 times 1/2, -1/2. Okay, so f divided by g of -1 is the same thing but division. So plug in that -1 is your x, plug it into f of x, and you get -4. Plug it into g of x, and what is that? 1? See, -1 plus 2. Why am I not showing my work? It's just 1 over 1, which is 1. And then you divide. So -4 divided by 1, -4. Any questions yet? Not too hard. Okay, try number 4. See if you can figure out that one. You got it?
Is it going that way plugging?
No, 4's the same way. Now we're just subtracting. So plug in 2 into the... Oh, wait, I did it backwards. Okay, this one should be first. Still, I plug in 2, so I have 1/4. And then plug in 2, here I have 6 minus 1 is 5. But it's not the way I wrote it. It should be 1/4 minus 5, which is -4.7. Yeah, so be really careful. I almost messed up. Pay attention to the order. So if G is written first, then it should come first when you subtract. Okay, the next 3 all have the open circle, so the f of G of. I wanted to change number 5 because it's the way it is on your test. And instead of doing f of G of x, let's do f of G of 4. Okay, so let's put a number in for x. That changes things a little bit. Okay, so what do you do with the open circle? What?
This X is on our
This is how it is on our test.
One of them is like that. Well, these all said x, but there's one of your tests that has a number, so I wanted to make sure you knew what to do with the number.
Okay.
What do you do with the number?
You plug 4 into G and then G into X.
Okay, yeah, so you go backwards. You plug in 4 into the G function, so 1 over 4 plus 2 is 1/6. And then you take that answer and plug it into the F function. So 3 times 1/6 minus what's that? 3 times 1/6 is 1/2 minus 1, so -1/2, -0.5. Okay, now the next 2 have an X and number 8, but it's different. So what do you do when it's just an X instead of a number?
Plug the whole function into where X is in the other.
Right, and just make sure you work backwards. So you start with the second one, the last one, plug it in to the first function. So you're going to take the whole f of x and plug it into the g function. So f of x is 3x minus 1. I'm going to plug that into the g function, 1 over x plus 2. So wherever the x is, I'm going to write 3x minus 1 and then plus 2. And then you simplify it if you can. There's not a whole lot you could do to this one, but you can simplify it a little bit. So it'd be 1 over 3x plus 1. Yeah, negative 1 plus 2 is just 1. So 1 over 3. No. No. I won't go into why, but it has to do with the other chapter. Factoring and such. Let's just say no. Leave it like that. Okay, 7's the same thing, just different functions. So take the g function, plug it in for f. So g of x is 3x minus 2. I'm going to plug that in for x. Ooh, this one's a little harder. So I have 3x minus 2 squared. 3x minus 5 squared. Minus 2 times 3x minus 5. Now we need to simplify that. How do you simplify 3x minus 5 squared? Foil. So either write it out, I don't have a lot of room, but you're going to foil. So it would be 9x squared minus 15x and 15x is 30x plus 25. I choose the shortcut to foiling, but you can also write it out twice and foil. And then what do you do with the negative 2? Distribute. And make sure you distribute the negative. Okay, I hate for you to get that far and then messed up because you didn't distribute a negative. So it's negative 2 times 3x is negative 6x. Negative 2 times negative 5 is positive 10. And then it's easy. Just put like terms together. So you'd have 9x squared minus 36x plus 36. That might be the hardest one. Maybe. Possibly. Requires the most work, just because you have to put it. Okay, so f minus g of x. I remember doing a worksheet. Ooh, I think your class actually didn't do this worksheet because of the assembly. But the x confused a lot of people when it was minus, plus, times, or divide. If it's x, that just means you're going to leave x in the problem. There's no number to plug in, so you can just ignore that if you want to. It's just f minus g. You're just subtracting the two functions. So it's the f function, x squared minus 2x, minus the g function, 3x minus 5. There's nothing to plug in. It's just of x in parentheses. Now you're just simplifying, putting like terms together. Again, the only trick is that you have to distribute that negative. So it's really negative 3x plus 5. So the answer would be x squared minus 5x plus 5. Okay, so that's all the problems over functions. That's 7 problems out of about 20, I think there's 23 questions on your test. So that's quite a bit. Any questions over that? Have to be really careful when you plug in the numbers. Okay, number 9 looks confusing, but I just changed it on the test. So here's the way it's going to read. You're going to have a function like that, or that's the equation for a parabola. Instead of saying a is greater than 0, h is greater than 0, and k is less than 0, I gave you actual numbers. So let's just make up numbers for a, h, and k, and I'll show you what I mean. So a greater than 0. So someone give me a number that's greater than 0. 2. No, y'all are on the same wavelength. H is greater than 0? 3. 3. And something less than 0. Better? No. Negative 1. Negative 27, sure. Okay, so let's just write that in the equation. So you have 2x minus 3 squared plus negative 1 or minus 1. So it just says in what quadrant does its vertex lie? So it looks really confusing, but really it's just wanting to know the vertex. Do you remember the vertex? HK?
3 and negative 1.
3, negative 1. And remember your quadrants are 1, 2, 3, 4. So where would that lie?
4.
4. over 3 down 1 would be in quadrant. Okay, so again, on the test, instead of putting like a is greater than 0, I put a equals something. H equals something. So you just have to figure out the vertex and where it is. Okay, turn your paper over. Let's graph each parabola, identify the vertex, axis, domain, and range. You can use your calculator to help you, but you could also do these using the formulas. I'm going to let you use those little formulas. You remember the little table that we filled out?
Yeah.
Yeah. Make sure you know where that is. I'm going to let you use that on the test. So it will hopefully remind you what the vertex, the axis of symmetry, the domain, and the range. How to find those. Okay, so 1 minus x squared. If you want to just use the calculator, try it, graph it, see what it looks like. Can you even see your calculator? I can't.
Put it under the light then.
Well, I was trying to type. Can you tell what the vertex is? That was pretty easy to see. 0, 1. Okay, and just sketch a graph. Doesn't have to be great. 0, 1, and at least goes through negative 1 and 1. That's the easy part. Now the axis of symmetry. So again, you get to use the formulas, and this should be written down. The axis of symmetry, if it's f of x or y equals, that's a vertical parabola. And so the axis of symmetry is x equals whatever the x is of the vertex. So this one is x equals 0. I'm telling you right now, if you just put 0, it's going to be wrong. Because it's a line, so you have to have x equals, or if it's horizontal, y equals. Okay, that's simple, but make sure you do that. Okay, do you remember what the domain is? Yep, negative infinity to infinity. Told you it was always that way. The range is not negative infinity to infinity. Where does the range start?
1.
Yeah, so it's 1 and it goes down. So at the bottom's negative infinity. This is 1. You usually write it from smallest to largest, so negative infinity to 1.
Is it going to be wrong?
I don't know. Try to write it from smallest to largest. You can do that. Even if you write 1 to negative infinity, then just look at it and just rewrite it. Switch it. That's easy. Okay, number 11, same thing.
Will the domain always be negative infinity?
It will on the vertical parabolas. It looks like this, up and down. So, here's x squared plus 4x plus 1. Can you tell what the vertex is? If you're not really sure, that's where you'll get to use those formulas at negative b over 2a. So it's negative 4 over, what's a? 1. So it's negative 2, and then just plug in negative 2 for x. And it's negative 3. So you have to be exact. So if you can't tell exactly what it is in the calculator, you'll plug it into the formula. So negative 2, negative 3. Something like that. What? You can see it. Uh-huh. It's not. It might look like that. That's why I said you might want to use the formulas. It's not really. Well, negative 2, negative 3. Right. Okay. So are you saying you disagree with the vertex? Okay, what's the axis of symmetry? X equals negative 2. Domain is negative infinity to infinity. And the range goes from
-3 to infinity.
-3 to infinity.
Good job, Clara.
Okay, number 12 is different. It says x equals, and I know you don't have your formulas out, that's fine, but do you remember if it's x equals, it's too dark, I can't find it. Sorry, if it's x equals, what does that mean about the graph?
Right.
It's either left or right. But the way it's written, you can't do this on your calculator, but the way it's written makes it really easy. This is vertex form, and this is where you get to use your formulas. The h is what's outside the parentheses. The k is what's inside. So the vertex is -1, -3. Okay, why did I put -3 when it's just 3?
You change it, the sign.
Yeah, you change the sign when it's in parentheses. So -1, -3. And then do you remember how do you figure out which way it's going? Which way it's pointing?
The A that's outside.
The A?
is positive.
The A is, in this case, positive, so which way does it go, left or right? Right. When it's horizontal, the axis of symmetry is y equals whatever the y is, so y equals -3.
What do you look at to see if it goes left or right?
This first thing, if it's x equals, it's left and right.
No, I
Oh,
mean, like-
okay. The A, so in this case, A is just 1. There's nothing in both parentheses. If it was -3, it would go to the left.
So it's a positive number, it goes
To the right. Yeah, and you should have all that written down on that table.
yeah.
But yes. Okay, domain and range is different. Are you watching? Because I don't know if we did this on our homework, but you can do it.
You didn't.
Okay. I tried to make it easy on you. This is not hard though. The domain is left and right. So does this one go forever to the left and right?
Yes.
No.
Oh, infinity.
It doesn't go forever to the left and right. So the range is -infinity to infinity. It switches, just like everything else switches. The domain and range switch. So now the domain, someone said it, where does it start?
Negative point.
It goes from -1 to positive. And the range is now. So it goes forever up and down. It doesn't look like it. Okay, those are going to be worth a lot of points because you have to find so many things, so don't skip them. Mark out number 13. We're not doing that. Keep going.
Let's stay together.
So on to number 15. It says describe how the graph of y equals all that stuff relates to y equals x squared. Well, there's a couple things, and I have this written on the test, so you don't have to guess what you're looking for. But first of all, what's the vertex?
-3, -4.
Yeah, remember h and k? So it's -3, -4. It's the opposite of whatever's in parentheses. So just write that down first. That means that the graph is 3 to the left, 4 down, but just write the vertex. It's fine. The A is 2. That tells us two things.
Positive.
Positive, so what does that mean about the graph?
Up.
Yes, so it points up, upward. And then it tells us the width, and it's 2,
Narrow.
it's narrow.
I can guess.
Questions?
So we
Okay.
don't tell how it relates to the
We
graph.
did. It points up. It's narrower, and the vertex is -3, 4. The vertex is the origin, so you're saying it moves. It's fine. Basically, you did. You're good.
That's fine.
Okay. Some people were really good at these, some were not. The symmetries. There's 3 types of symmetries. Symmetric to the x-axis, symmetric to the y-axis, symmetric to the origin. To figure out if something's symmetric to the x-axis, we are going to plug in -y. For the y-axis, you plug in -x. For the origin, you do both. And then you see if you can simplify it and end up with the same thing you started with. You ready? We can go back. So first I'm going to plug in negative y. So if you missed this, can't remember who wasn't here. Pay close attention. So I put a negative y where the y is. Can I simplify that at all?
No.
No. There's nothing I can do. Does it equal what I started with in a function, original function? No. So it's not symmetric to the x-axis. Okay, so for the y-axis, I'm going to plug in negative x. So I have 2 times negative x squared plus y equals 10. Well, we did this one like this the other day. Anytime you square a negative, what happens? It becomes positive. So basically that negative x squared just becomes x squared. Is that the same thing I started with?
Yeah.
Yes. So it's symmetric to the y-axis. Now let's check the origin. So origin, I plug in negative x and negative y. I can simplify the negative x squared, but can I simplify the negative y? No. So is that the same thing I started with? No. So this first one is only symmetric to the y-axis. Is that too fast? Let's try the second one. So same thing. First plug in negative y. 2x minus y equals 0. Can't simplify it. It's not the same. Plug in negative x. Oops.
You have to work it out if you automatically.
Nope, you can if you can see it, that's fine. Now that one I could make 2 times negative x negative 2x. But is it the same? No. Now here's the only place you have to be careful. It's tricky. 2 times negative x minus y equals 0. So I get negative 2x minus y equals 0. It looks different, but if all of one function is positive and all of the other function is negative, you should know this, just as a basic rule of algebra. What can you do to get rid of negatives? Multiply or divide by negative 1. And you change everything, so it's the same. So this one is symmetric to the origin. Okay, that didn't work on the x-axis or y-axis because, like, let's say on this one I want to get rid of that negative 2x, so I divide by negative 1, but that makes that a negative y, which is still not the same. Okay, so it only works if everything's negative on one equation and everything's positive. Okay, you try number 18. Either you can do it in your head or write it down. See if you can figure out which ones it's symmetric to. It should be pretty easy when they're something squared. Anyone know? All three, right. Something squared makes it positive, so every single one of them is the same thing. Say all. Okay, we're almost done. Now we're to the easy ones. It's all graphing. Okay, give the intervals where it's increasing, decreasing, or constant. We did that on Thursday. We didn't talk about constant, but constant means like a flat line. It's not changing. So where is this increasing? Tell you what, before I even ask that.
-3.
Let's see, here's what'll make this easier. Just start from the left. Okay, so I'm starting here. This is negative infinity. What is the graph doing at first? I'm always going to go from left to right. Okay, it's missed. It's decreasing from negative infinity to what? Negative 3. If you need to, draw some lines. Okay, so it was decreasing from negative infinity to negative 3. Okay, so just keep going from left to right. Now from -3 to 1, what is it doing? Constant. Good. It's always the x's. You don't care about the y's at all. And then from 1 to, this would be infinity, what are we doing? Yeah. Okay, 20, that's what we just went over today. You can use your calculator, it's matching. I'll just give you the answers. You can probably tell by looking. Maybe some of you can. A is A. B, graph B is, letter B is C. C is B, and D is D. But just use your calculator. So 21, use your calculator as well. That's what we did today. Do you want to try it? I'll just show you. It goes over, the vertex is 1, 0. So make sure you get the vertex at the right place. And then it'll look like this. Okay, number 23. So this is the other thing we did today. Let's see if you're getting this. So where do I put my dotted line if you want to put a dotted line? -2. So to the left of -2, I'm going to graph x plus 1. To the right of -2, I'm just going to graph -1. Y equals -1. So you can still use your calculator to help. I didn't look at your homework. I should have been walking around to see if this is confusing to anyone. But so we're only going to graph this to the left of -2. So figure out, at -2, where does this line go? Let's see. Can you see that? 1, 2. At -2, look at your calculator. How far up or down does it? It goes down something. Think down just 1. And it is a closed circle. To the right of -2, we're just graphing y equals -1. Do you know, without using your calculator, what that looks like? Straight line on -1. Well, it should, but they ended up connecting, so. Last one. Okay, so x is less than 2. We're going to graph absolute value of x, and then to the right, graph this. So why don't you try this on your own, and I'll see if you're right. Since I won't have a chance to grade your homework before the test, and then I'll just see if you understand this. So everyone try it. Put your calculator out.